Hi, my name is Chandan Kumar Sinha, and today I'm going to talk through project assignment we have for machine learning foundation for product manager. This is the final project assignment we have that will be peer reviewed us. So there is a little background on the project itself. So in this project, we'll build we've been asked to build a model to predict the electrical energy output of a combined cycle power plant which uses a combination of gas turbines, steam turbines, heat recovery system, generators to generate power. We have been given a data set in a CSV format, which is a set of around 6568 hourly average ampere reading from generators at the power plant, which we will be using for our model. Talking about the data set, the different columns or values that we have or variables we have in this is temperature, ambient pressure, relative humidity, exhaust vacuum. These are the input features, and as the output, we have the net hourly electrical energy output itself. So, as I was saying, I have already downloaded the data set which was provided in a CSV format. Now, looking at this is a complete list of data sets we have, and I'm going to quickly walk through the approach itself that I have taken for this project. So, the type of modeling approach we have taken is a multiple regression analysis. I considered two different models for this to review the project. The first one is using all the input feature that you see here, which is the temperature, exhaust vacuum, ambient pressure, relative humidity, and for the model 2, I limited it to two different inputs, which is that first two, which is temperature and the exhaust vacuum. From the dataset point of view, I have taken 705 15 ampere split, which means 70% of this data from the set that you see on the screen is used for training, 15% for validation, and the rest 15% for testing. And for validating the model, I am considering two different values. The first one being is the R square or the MSSC, and the second one being the residual difference, which is the accuracy. And since we were given couple of different options that we can use to build a model, I am using the approach model I am using is the option I am using the Microsoft Excel one. As you see, we are using all the different input model. Here we broken down the data into three different groups, which is training, validation, and testing. As you see here, the resultant R square value for this is 93, which is really good, and you can also see the accuracy right on top of the accuracy range here. And this was done using the data analysis options right within Excel. And moving on to the model 2, as you can see here, we are using the temperature and the exhaust vacuum here, and the same approach 70 15 15. And as you see here, the R square value is 91, which is again good. And if you see here the accuracy range, it is still little on the more wider range as compared to model 1. So based on the two different approaches we have taken, or two different models, we have the conclusion or the recommendation is to go with the model which has higher R square value in this case, which is model 1, even though it's a slightly better one. But when we look at R square and the accuracy range, both of them is better with model 1. So again, the conclusion is to go with the model 1 for this. And so yeah, that's my finding, that my project assignment. Thank you for time, and I appreciate your listening, and thank you.